Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Okay, I'm going to solve the assessment number one, which I took today in the class. So I thought it better to solve it myself so that most of you can know a better way to solve a question. Okay, so the first important thing is you have to read the question very carefully. So this is a smooth pebble made from uniform rock and the shape of an elevated sphere is shown. L is the length and R is the radius. So over here, the length of this sphere is given, this rock is given, the radius is given, and the mass is given, along with the absolute uncertainty. So this is delta L, this is delta R, and this is delta M. Okay, next thing is, the first question is you have to state the name of the measuring instrument suitable for making the measurement of L. Okay, this L is actually 0.142 meter. And when you multiply it with 100, so you can convert this into centimeter, which is like 12.42 centimeter. So in 12.42 centimeter, there are two decimal places. Now we have to look for one thing, that if we use a ruler to measure anything, we write its answer in one decimal place as its least count is 0.1. If we use a vernier caliper, its least count is 0.01. So we write every answer measured from vernier calipers in two decimal place as its least count is having two. And then screw gauge. So for screw gauge, it's 0.001 centimeters, so three decimal places. So it means 12.42 is in two decimal place. So we have used vernier calipers. So vernier calipers or simply calipers is the answer. Next thing is you have to find the percentage uncertainty in R, right? So like this R, you have to find the percentage uncertainty. So it is like delta R over R into 100%. This is known as percentage uncertainty in R. And delta R is 0.0004. And then R is 0.0420 multiplied by 100%. So your answer comes out to be 0.95%. So you will write it as it is. Don't convert this into one significant figure because it is only the percentage uncertainty. So you can write this into significant figure as well. Why? Because look, the least value is having one significant figure. So the rule is the answer must have same significant figure or one more than least. So 0.95 is fine. Next question was quite easy. Most of you did well. The density equation is given and you have to show that the value of n is -2. This is through the SI base units. So what you do is you simply put the SI base units for all of these. So let's say for, you can do one adjustment. You can take K and L to this side and then this will be MRN. So density is kilogram per meter cube. And K is a constant with no unit. So K has got no unit, L is length, meter, mass, M is mass, kilogram, and R is again radius, M power N. Now what you do is you compare indices of meter on both sides. So comparing indices of meters on both sides of the equation. Okay, so we say comparing indices of M. So on left side, it is -3 plus 1, and on right side, it is n. So it is -2. So n equals -2. It is true. Okay, let's move to next part. Calculate the percentage uncertainty in rho. So for rho, you have to use this formula. So we know that it is m and r value is -2. The n value is -2, which we just have calculated. So now next, what you will do is you will move this r to the denominator. So rho is m over KLR squared. Now you have to write the percentage uncertainty, and as absolute uncertainties are given over there, so what you will do is you will add the fractional uncertainties. So it is like delta rho over rho into 100 equal delta m over m plus delta L over L plus 2 times delta R over R, because it is R square power rule. So when you put the values, all values are given. All values are given like over here. You have all the values of delta L, delta R, delta M. So when you put all the values and after carefully calculating their answer, the answers comes out to be 2%. So this is like 2%, right? Okay, then you have to determine the density with its suitable uncertainty. So we say, okay, first you have to find density. So it is like m over k l r square. So you have all the values, like you have all the values over there. Like this is m 1.072, this is r, this is l. Simply put the value and solve it, and you would get the answer as 2336.7. So this is density. Now for the absolute uncertainty, you already know the percentage uncertainty in density, which is 2%. So what you do, it is 2 divided by 100 multiplied by density, right? So 2 over 100 into 2336.7, and the answers comes out to be 46.7. Now over here, you have to write the uncertainty in one significant figure, so that must be 50, because 46.7 is having three significant figures, so you have to write in one, so you round it off. And then for the next thing, for this density, it must have the same decimal place, and it must be multiple of this uncertainty, so it should be rounded off to 2300, right? Because 2300 is a multiple of 50. Okay, the two SI base units beside ampere, meter, and second. So one is kilogram and other is Kelvin. It can be mole, it can be candela. And then you have to find over here in next part, you have to find the unit of mu. So the first thing is you have to make mu as the subject. So it is VE divided by F. And then you have to put the like the units. For speed, it is meter per second. For E, it is charge. You know, E is charge and charge is IT. So I is ampere and time is second. So it is ampere second divided by force. Force is MA, which is kilogram meter per second. So now you can cancel some terms, like over here. One thing is that it is 2 minus 2. Okay, now what you do is these two are being cancelled away, and then you're left with kg minus 1, right? And this meter and meter also cancelled away, and A, and when S moves up, it should be plus 2. So your answer is kilogram minus 1, AS2. Okay, let's move to the next part. The distance between sun and earth is this, express this in gigameter. Okay, so giga, you know, giga is 10 power 9. So you'll say 1.5 into 10 power 2 into 10 power 9. So you split 10 power 11 into 10 power 2 and 10 power 9. So 10 power 9, you know, 10 power 9 is giga. So write giga at its place, and 1.5 into 10 power 2 is 150. And giga is already written over there, so no need to write giga. So 150 is the answer. The next question is an analytical one. It says that the distance from center of Earth to the satellite above the equator is already is given. And then the radius of the Earth is given, and a microwave signal is sent from a point on Earth directly below the satellite. Calculate the time taken by microwave signal to travel to the satellite and back. So it means that, let's say if this is Earth, and its radius is given, and a satellite is here, and then from satellite to center of Earth, the distance is given, and then radius of Earth is also given. So you know when this signal will be moving up and then coming down, so how much time it takes. Okay, so we will say that actually we have to use formula V equal d by t, and from here t is d by v. So how much is the distance to and fro? You know that this is distance from center of Earth to the satellite, and this is the radius. So we have to subtract them, and we have to multiply that distance with 2, because that signal is going up and then coming down. So we say 2 times of 42.3 into 10 power 6, because that is mega, minus 6380 into 10 power 3. So that is the distance, and whole divided by V is the speed. Speed of microwaves is 3.0 into 10 power 8, right? So the answer is 0.24 seconds. Okay, The next is quite easy. You have to show that C has got no unit. So the first thing is take square on both sides and then make C as the subject. So it is V square rho over P, and then fill in all the units. So speed is like speed square is m2 s minus 2, density is kilogram per meter cube, and then pressure is force over area. Force is ma, so it is kilogram meter per second square over meter square. 1 meter is gone, so it is kilogram per meter per second square. So cancellation here, kilogram, and then second, and m2 and m minus 3 is m uh, minus 1 and m minus 1. So cancel the way. So C is 1. It means it has got no unit. Okay. The next thing is you have to find the wooden meter rule mass in kilogram. So that is ranging from like 100 to 200 gram. So you can write 0.1 kilogram to 0.2 kilogram, anyway between that. Then the volume of the cricket ball, cricket ball is a sphere, 4 by 3 pi r cube. And then approximately the radius is about 3. So the answer is almost like 115 centimeter cube approximately. Okay, then determine the SI base unit of stress. Stress, as I told you, stress is like pressure. Stress is like pressure. So pressure is force over area. And then it is force is MA and area is M2. So 1 M cancel away. So it is kilogram per meter per second square. Okay, next question is a numerical. All the data is given over there, like the mass is 500 gram, the length is 60 centimeter, the breadth is 630, and D is 5 millimeter, and then the time period is 58, and you have to find E in gigapascal. So as we have to find E, so you have to make E as the subject. So let's make E as the subject. So take square on both sides. So it will be T square equal 4 pi square 4 ml cube over E B D cube. Now make this E as the subject. So E is 4 4s are 16 pi square ml cube over T square into BD cube. And now, beta, you have to put the values. So 16 pi square into M. M is 500 grams, so it is 0.5. L cube. So L is how much? 60 centimeters, so it is 0.6 cube. Then T square. T is 0.58, so 0.58 square. And B. B is 30 millimeters, so it is 0.03. And then D. D is 5 millimeters, 0.005 cube, right? So when you solve it, you will get an answer of 1.352 into 10 power 10. Now, as you have to express this in giga, so we can write it as 1.352 into 10 power 1 into 10 power 9, because you split that up. So 10 power 9 is giga, so don't write it because giga is there. And then multiply these two together, so it is 13.52 or 13.5. This is your answer. Okay, which expression has the same SI base unit as pressure? So, pressure is force over area, and it is kilogram meter per second square over meter square. This cancels away, so this is kilogram per meter per second square. So what you have to do is you have to put the SI base units of force, length, and speed, and see. If you look at option C, unit of mass is kilogram, unit of length is meter, and unit of time is second square. So that comes out to be kilogram per meter per second square. That is exactly matching with this. That's why C is the option. What is the approximate speed of sound in air? Sound. So that's very common. 300. In air, it is 300. Which row shows the quantity and incorrect unit? So it means three quantities will be with correct unit. So efficiency, no unit, yes. Moment of force is force into distance. Force is Newton, distance is meter. But over there, they have written Newton per meter. It means this is the wrong unit. incorrect unit, which we have to look for. That's why B is the option. And momentum, okay. Question number 9, which experimental technique reduces the systematic error of quantity being investigated? Systematic error. So, systematic error is due to fault in instrument. So adjusting an ammeter to remove its zero error before measuring a current? Yes, that's the answer. Measuring several internodal distances and then using mean? No, mean is used to reduce random error. Measuring the diameter of wire repeatedly and calculating the average? No, it's again for random. Timing a large number of oscillation to find period? No, it's for random. So its mean option is A. And then they're saying that the correct value of a steel, of a thing, of a bar made with steel rule is 895. This is the accurate value. And they have repeated values like this. And you have to tell that are the readings accurate and precise within 1 millimeter. So it is clearly visible that all the readings have a deviation of 1 millimeter. It means their precision is high. But if you can see the true value is 895 and the average value is around 891, so the deviation between these two is 4 millimeter, which is of course more than 1. It means it is not accurate. So it is precise, but it is not accurate. So it is precise, yes, but it is not accurate. So the option is B. So students, I hope that you have got all the concepts involved there. In case you didn't get any concept, then feel free to contact me.